You may not normally think about semiconductors, but they are an essential part of all of our daily lives. For example, in smartphones, the microphones used when talking, the shutters used when taking photos, and various other features and functions are all driven by semiconductors. There are also a wide variety of different types of semiconductors. For example, semiconductors, which are referred to as CPUs in memory, process massive amounts of electrical signals at high speeds and act in ways which are the equivalent to the brain and nerves in a human being. The processing power of modern smartphones is said to be much greater than that of the Apollo computer systems, which first carried humans to the moon. And semiconductors continue to become more advanced every day as they support more and more of our daily lives. This video will provide answers to the question, what are semiconductors? And provide easy explanations about the world of semiconductors. Basis of semiconductors: materials that conduct electricity and materials that do not conduct electricity. Semiconductors are materials which are able to easily conduct electricity at a level about midway between conductors and insulators. Silicon is currently the main material used for semiconductor components, which are essential to electrical circuits. So why are materials which only partially conduct electricity used? One might think that it would be better to use materials that more easily conduct electricity for components, which conduct large amounts of current such as power semiconductors. So why are semiconductors used? If talking just in terms of ease of electrical conductance, metal would be clearly superior to semiconductors. But what is interesting about semiconductors is that they can conduct current or not conduct current depending on conditions. Metal cannot be made to not conduct electricity. However, semiconductors by their nature can rectify and control this condition. A silicon atom has 14 electrons around the nucleus, and of these, there are 4 valence electrons on the outermost orbital. When this is made into a single crystal, it can be used as a material for semiconductor products. When it crystallizes, the nuclei share electrons and they bond with 8 electrons around each nucleus. Electricity for the most part does not conduct in this pure monocrystalline silicon state. Doping silicon with other impurities changes it so it's conductive. The semiconductor is categorized as a p-type or n-type depending on the type of impurities that are doped. Junctions based on p-types and n-types are integrated into one chip in order to use it as an electronic component. This electron is extra in this structure. This is a free electron. When voltage is applied, it changes to a state where the electron is drawn to the positive and can move freely, allowing current to flow. Here, this state leaves a vacancy where there's no electron. This vacancy is called a hole. The hole can also be called a virtual particle because it is void. Electrons are drawn to the positive pole and move to close holes. Then, as the electrons move to vacant holes, new holes are created and then the adjacent electrons move to the new vacant holes again. As this process is repeated, electrons move toward the positive pole, and at the same time the holes appear to move toward the negative pole. Only electrons are actually moving, but the holes can be considered as having positively charged particles. What is an n-type and p-type semiconductor? The movement of electrons and holes in a semiconductor. Electrons move toward the plus pole. At this time, current flows in the opposite direction of the electron's movement. Electrons are what is actually moving, but the holes appear to be moving toward the direction of the minus pole. As a result, both p-type and n-type semiconductors can have current flow, but they are not as conductive as metal. Therefore, there is no need to use semiconductors if the only purpose is for current flow or conductivity. The advantages or characteristics of a semiconductor are its ability to allow or stop current flow based on certain conditions. The basic principle behind a semiconductor is its rectification behavior using a p-n junction. When voltage is applied to the p-n junction so that P becomes plus, the holes and electrons can be moved toward the interface. When the holes and electrons meet at the interface, or junction, the electrons jump into holes and both are eliminated. After those electrons are eliminated, more electrons flow into the N layer and electrons flow out from the P layer, creating new holes. This is repeated, enabling the current to continue to flow when voltage is applied in the reverse direction of the p-n junction. Voltage is applied to the p-n junction so that N becomes plus. Since the holes and electrons move away from one another, they do not meet at the interface and the current cannot flow. A region forms close to the interface called the depletion layer, which does not have any holes and electrons, and this produces voltage withstanding. As a result, we know that there is a rectification behavior in the p-n junction. Among the devices that use semiconductors for materials, there are power semiconductors, which are made for the purpose of handling or processing large currents and power. There is no clear line, but power semiconductors are generally categorized as having a rated current of 1 amp or greater. The following types are common devices. This sheet is categorized for each semiconductor. General rectifying diodes, fast recovery diodes, Schottky barrier diodes, and Zener diodes all consist of diodes. Bipolar transistors, MOSFETs, and IGBTs all consist of transistors. SCRs, silicone surge protectors, and TVs all consist of thyristors. Power ICs and power modules are others. In addition to categorizing based on the operating principles of the semiconductor chip or the elemental structure, the products are also categorized based on the package configuration and based on their function, which is determined by the number of elements or connections built into one package. Thank you for watching this video. Please don't forget to hit the like button. And please subscribe to our channel if you're interested in seeing more videos like these. See you next time.